So this is one of my first boards I made. And actually I made four of them. I didn't make four. I made three. I drilled out the plastic for four, but I only made three of them. Two were on a location, and this is the third one. And it works pretty well. It'll set to any voltage because there's nothing on here that defines it. So this is the what's up meter. And as you can see right here is a test button. It's a reset button that will reset the values on the meter. There's no switch on here, so the switch would be from off a panel, off your setup. The input comes in here from, down here. Fancy here. So right here is where the three wires will come in, and from your PMG or your PMA without the rectifier in it, which then makes it a PMG. And then it comes over to the switch, which is your brake switch, and also will cut it out temporarily while you maybe doing some work on it. Then over here it's going to the rectifier. It's mounted on a electrical box to give it some distance off the wood. I don't think it would ever really get hot unless you're really pushing it to its limit. And then we have the what's up meter. This one goes for about $60 on eBay, $50 on eBay. And it's kind of what a lot of people compare life to. 14 gauge wire versus the new ones that I found, the iMesh ones that are 12 gauge wire. And then the output is up here. Like I said, I don't have a shut-off switch here or a breaker. Then from here it would go to the batteries, or you could probably also send it to a plug-in grid-type inverter if you so wished. It's a basic system. This is, like I say, the first ones that I built, and I've used them, and they work pretty well. And it's just a way, basically all this does is it gives me the option to be able to monitor the power coming out of the PMG, and it's a pretty simple layout. But I just thought I'd share if somebody was thinking of doing something like this for themselves. It's not that hard. I mean, there are people out there that build systems for you, and but if you're doing this, you want to have something like this because you don't want to accidentally throw the brake if the PMG is turning. It could burn out because you're going to basically feed back all the lines back into the coil and give it nowhere for the power to go, and that could actually burn out your coil. So it's a good idea to say that. Now, sometimes when you bring your PMG down, your turbine down on the tower, the tail goes down and then the blades are up and it's not going to really turn. But from a safety point of view, when it's on the ground, you don't want those blades spinning when you don't expect them to. So that's why it's good to have a brake circuit in there for you. But it's good to have it safe, that it's not going to be flipped by accident when someone's playing around. So that's it. It's basically, you probably already have most of the components. It's the way you can add the what's up meter. It's nice to have the switch. Now the what's up meter actually gives you the pin layout for these. And maybe it's the same for all of them, I don't know. But basically it's 3 wires. 2 wires does the reset. The other wire is for supplying a battery. Some people use this what's up meter for monitoring the output from a battery, and there are other applications, and they have an external battery to power the unit, like a transistor radio battery or such. And that way, if the battery is removed, like say for example, something like a car, race car or something, remote control, and you take the battery out, you lose your values, and you might want to hold on to them for a while, so you could have an external battery. I don't think we really care when it comes to what we're doing for off-grid, because you're basically monitoring what your output is. But that's kind of where that's at, and it's just a little simple design. I thought I'd do another video on it, talk a little more about it, and check out this meter here. This is it's a really nice analog meter. I actually picked it up for, I took the price tag off of it, but for $3 at a Restore store from Habitat Humanity. They have a store that people donate building products, and it was $3. I had to buy my own leads, but and you put a battery in it. There's some nice things about analog meters, and only probably if you study electronics that it has its uses. It doesn't need any power to run, for one thing. The only thing the battery is for is to run the ohm meter for checking resistance or continuity. Other than that, there's no need for a battery in an analog meter. That has its advantages. The other thing is you can see pulses with this type of meter versus most of the digital meters. You can't see pulses unless you've got a really good fluke meter or a really good quality meter that might cost you $100. But so the digital meters are handy for seeing pulses, and that's a handy thing sometimes if it's something you care about. Anyway, ta-ta, YouTubers. Enjoy.